Everything has to end eventually, but does that include the universe itself? And if so, how and when? It might be hard to imagine a catastrophe big enough to affect the entirety of existence, but physicists do expect it all to end at some point, and it may come sooner than we think. Here in this video, some of the leading hypotheses about how the universe could end and when. To figure out how the cosmos could come to a close, physicists look back to the beginning. About 13.8 billion years ago, space and time burst forth from an incredibly dense singularity, an event that's come to be known as the Big Bang. The universe rapidly expanded from that point, with matter cooling and condensing into galaxies and all the stars and planets they contain. But the universe is still expanding, and doing so at an accelerating pace, thanks to a mysterious force that scientists call dark energy. As that name suggests, we know very little about how this force works or why it's pushing everything away from everything else, but it has some pretty major implications for the ultimate fate of the universe. How it plays out depends on how you tweak the numbers in the models. So let's dive into this video and go a little deeper to see what these theories has to say. The Big Crunch. Perhaps the universe will end in the exact opposite way. Instead of expanding forever into nothingness, it changes course and collapses in on itself in a so-called Big Crunch. In the cosmic tug of war between gravity trying to pull everything together and dark energy trying to push it apart, scientists usually stack their chips in favor of dark energy, which would ultimately lead to a big freeze or big rip ending. But we can't completely count gravity out of the running. If the density of matter in the universe is high enough, its gravity could overcome the expansion and trigger a contraction phase instead. Everything will begin to move towards everything else as the universe shrinks once again. Much like our current expansion phase, anyone alive at the time wouldn't be directly affected, at least until near the end. Galaxy clusters would start to merge, then galaxies themselves, and eventually individual stars would collide more regularly. But the real trouble begins with the cosmic microwave background, the background radiation of the universe left over from the Big Bang. As its photons are shifted towards the blue end of the spectrum, this radiation heats up until eventually it becomes hotter than stars. That means the stars can no longer radiate their heat outwards and will continue to get hotter and hotter until they evaporate. In the last few minutes, the temperature of the universe would be so extremely hot that atoms themselves would fall apart. Not that they'll have long to worry about that, since they'll be sucked into the black holes that are taking up an increasing percentage of the shrinking universe. Eventually, the entire contents of the universe will be crushed together into an impossibly tiny space, a singularity, like a reverse Big Bang. Different scientists give different estimates of when this contraction phase might begin. It could be billions of years away yet, or, according to a recent study, it could be quite soon, cosmically speaking, as the universe reverses course about 100 million years from now. In that model, the contraction phase would take about 1 billion years before we return to that singularity, the Big Freeze. According to our best models of the evolution of the universe, the most likely scenario is what's called the Big Freeze. If dark energy keeps accelerating the expansion of the universe forever, and calculations suggest that it will, then the cosmos is in for a slow death that's drawn out for a good few years. That unfathomable number is a 1 followed by 100 zeros. If you could watch a patch of sky and fast forward over billions of years, the stars would start to turn red, then fade out completely, That's because the expanding universe would stretch the wavelength of their light farther and farther towards the red end of the spectrum, before rendering them completely invisible to the eye. Of course, even if you couldn't see them, the distant stars and galaxies would still exist, at least for a few trillion years. But after a while, the expansion would dilute the dust and gas floating around in space until there isn't enough concentration in any one region to fuel the birth of new stars. With no more being born, stars eventually become an endangered and then extinct species as the last of them die off. So begins the universe's degenerate era, about 100 trillion years from now. By this point, only white dwarfs, neutron stars, and black holes exist, but these too will fade. White dwarfs and some neutron stars will slowly cool into invisible, inert black dwarfs, while other neutron stars will collapse into black holes. By the year 10 tredecillion, a 1 followed by 43 zeros, there won't be anything but black holes left. And even these aren't eternal, as Stephen Hawking predicted. Black holes slowly give off radiation until they eventually evaporate. After about 1 Google years, once all the black holes are gone too, the universe settles into its final age, the dark era. Light and matter are distant memories, and the remaining loose particles will live the loneliest possible existence, rarely having the chance to whiz within a light year of each other, let alone interact. And nothing else will ever happen for eternity. The Big Rip. A similar scenario leads to a far more dramatic death much sooner. In this model, dark energy doesn't just accelerate the expansion of the universe at a steady pace, it accelerates exponentially, eventually tearing the very fabric of reality apart, an ending called the Big Rip. There's a physical limit to the distance into space that we could ever see, even if you had the most powerful telescope possible. That limit is dictated by the speed of light. At a certain point, objects are too far away for their light to have had enough time to reach Earth. This region is called the observable universe. In the Big Rip model, the exponentially accelerating expansion pushes more and more objects beyond that boundary, meaning that the observable universe is constantly shrinking. Any two objects that are farther apart than this boundary allows can no longer influence each other through the fundamental forces like gravity or electromagnetism. The scientists who proposed this model predict that, if it were to happen, the universe has about 22 billion years left to live. Thankfully, though, other scientists believe that this scenario involves parameters that aren't realistic, so is less likely to occur than some of the other ideas on this list. So friends, what do you think about these theories? Write your views in the comment section. And don't forget to subscribe to our channel to get interesting videos. If you liked the video, please like and share the video.